Hello, this is Denton Yoder, instructor for BSE 2304, the Biological Systems Engineering CAD class. Um, I was just going to do a little side note today on Lisp. I've done several videos on Lisp, but I don't think I had done a wide flange beam before, so I thought I would draw one for you. So, start off with, we can draw anything manually. It's not that difficult. Oftentimes when you're drawing manually and it takes a little bit of math in your head, then it's easier to draw it programmatically. So we're going to develop this into a program. To start with, I'm going to draw a wide flange beam. I'm going to draw one that's 8 inches wide, 12 inches tall, using a ½ inch for the top and bottom flanges and a ½ inch for the web in the center of the beam. So to draw that, I'm going to start a polyline. Well, let me first show you how I would probably draw it. If I was drawing it by hand, I would normally just draw a rectangle at 8 by 12. I would explode that rectangle. I would offset a ½ inch for the top and bottom flange. And I'd draw a line in the center on the midpoint. And I would offset that, and I want a ½ inch, so I'd do an 1/8 inch left and right of center, which when I erase the center then would give me a ½ inch all around, trim up the extra line work that's not needed. And I've got, whoops, I need to trim a little bit more. Trim out here and trim out there. Okay, so now I have an 8 by 12 wide flange beam, and I was able to draw it actually fairly easily. I drew a rectangle, I did some offsets, I got the center line, I did some more offsets, did a little bit of trimming. Okay, now to try to automate that task. Another way to draw this beam is to just do the polyline command and say at 8 angle 0, I want to go up a quarter at 0.25 angle 90. No, not 90 meters. At 0.25 angle 90. Okay. Now, I want to go in an 1/8 inch short of the center. So I want to go to the left 3 7/8. So at 3 7/8 angle 90. Undo that. Undo. At 3 7/8 angle 180. Now I want to go up, and the overall height is 12, but I'm going to have a ½ inch at the top and the bottom that's short, so it'll be at 11.5 angle 90 at 3 7/8 angle 0 at 0.5 angle 90 at 8 angle 180. You get the idea. I can mathematically calculate at 0.5 angle 270 at 3 7/8 angle 0 at 11.5, no, it's a ½ inch. Oh, I got that wrong. Okay, at 11 angle 270 at 3 7/8 angle 180 at 3-7/8 angle 180 at 3 7/8 angle 180 at 3-7/8 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 5 angle minus 90. So in my head, I did calculations wrong. One of them is I made this leg too short, and so I need to stretch this up straight half an inch, I think, and then stretch this up. I don't know. I think I fixed it. I'd have to measure it to make sure, but it was a pain in the butt. Okay. Maybe that explains why we need a program. Okay, so to do programs in CAD, as well as symbols and everything else, I like to have a folder where I put everything. And I like to tell AutoCAD where that folder is. So if I go to right-click on the command area and go to Options, in the Files Support Path area, I can add a folder. Now, if you don't know about Google Drive, you're missing out. Let me just do a quick explanation. So in Google Drive, on the gear icon, you can get Drive for desktop, which will install a program that will let you see your Google space. Okay, so what I mean by that is I now have a G drive that has my drive, and I break it up by year and my VT CAD tools so that whatever I create is available in CAD. So if you're adding one to this, please do not change any of them that already exist. Add a new one, then browse to the folder that you've made. So you want to add one and then browse to it, and you're increasing the support file search path. Okay. Editing a file in that folder. Now, I already created it. I like my Notepad++ editor. Please forgive me. I've got the spaces being shown as little dots so I can tell when I'm using a tab or when I'm using a space. But let's talk about this. Now, this is a Lisp routine or a Lisp program. It's any file name .lsp. I use the function name, so I'm defining a function. The C colon means it's a command. Define a function, command wshape2, passing it no parameters. So I named my file wshape2.lsp so that it would match, which makes it easier for me to remember what to load. Now, I've got about 35 lines, 36 lines. 4 of them are a function, 3 of them are a function, which I probably ought to explain that once. There is a polar command in Lisp, which is real easy to set a point based on another point. The problem with polar is it works in radians, and I don't know if you remember your radians or not, but to go to the right, that is 0. To go to the left, it is pi. To go up, I divide pi by 2, which gives me 90 degrees, which would give me the number of radians for going up. And to go down, it's pi times 3 divided by 2, or 3/2 pi, to go down. And so I just made little variables, go right, go up, go down, go left, so I can use the polar command and I don't have to think about the radians. I can just say go left, go up, go down, that type of thing. Okay. The second half of the program, after the first 4 points, I said, oh, well, just let's forget about this go up, go down, go left. Let's make one that uses degrees instead of radians. So polar D, or polar D is one that I made up. The polar command wants to know the point you're starting at, the radians for the angle you're traveling, and the distance. I made a polar D, where it starts with the point you're referencing, the degrees you're traveling, and the distance. Now, all the polar D command does is do the polar command and take the number of degrees you type in and multiply by pi and divide by 180 to convert to degrees, or to convert to radians. So now I can use a polar function and type in degrees when I want to. So I could have continued this last half using polar with the go left, go up, go down moniker, or I've done it here with the regular polar command. Now, when you run this program, I store 4 variables: set quantity, W1 to be the width, HT1 to be the height, FLT for the flange thickness, and web for the web thickness. The web thickness is the vertical part. Okay, so now I'm setting the 4 values so that I can use the radians correctly. And now I'm starting. Store point 1, get point, where is the center of the column? So you ask the person where do they want to put the column, and they pick a spot. Okay, now it says point 2 is polar from point 1, go left half the width. Width divided by 2. So point 2 is going to be the bottom left corner. Well, from the center, it would be the center left edge. Point 3 says go polar from point 2, go down half the height. Now you're at the bottom left corner. A semicolon and text are comments in Lisp. Anything after a semicolon is comments. Okay, so point 3 is the bottom left corner. Point 4 says travel from point 3, 0, which is go right, width, and that'd be the bottom right corner. Point 5 from the bottom right, go up a flange thickness. Then from that point, go 180 or left, half the width minus half the web thickness, which would be the bottom right inside corner right next to the web. Then from that point, go 90 degrees or up the height minus 2 flanges. Okay, so now you're on the top inside corner. Then go to the right, half the width minus half the web. So you're in the upper right corner under the flange. Then go up a flange thickness. Go left a width. You're in the top left-hand corner. Go down a flange. Go into the center, half of the width minus half of the web. Go down the height minus 2 flanges. Go left. And instead of saying how far to go left, I said go up from the bottom a flange thickness. Which I could have said go from point 12, or excuse me, I could have said go from point 13 to the left, half the width minus half the web. But I found it easier just to say, okay, starting in that bottom left-hand corner, point 3, go up half a flange, or go up 1 flange, and you're there. Okay, so I've set out all the points to go around the polyline. And then I'm just saying polyline, bottom left, bottom right, up, inside, inside, outside, top, left, down, inside, inside, left, close. And that should draw the shape. And this command is wshape2. So I can close that. In CAD, to load a Lisp routine, is load wshape2 in quotes. And it says, hey, you sure you want to load this? I'm going to say, yeah, go ahead and load it. It should respond with a C:\, wshape 2, meaning I've learned a new command. Its name is wshape 2. And so if I type in wshape 2, it says what's the width, what's the height, what's the flange thickness, 0.5, what's the web thickness, 0.25, where do you want the center of the column, pick, done. So the idea is, if you record the path of how to create this thing, you can rerun it as many times as you want, drawing different sizes, without having to think and calculate on the additional times you draw it, which reduces the amount of checking you need to do, because if you check your program one time that you're drawing correctly, you should be good. All right. Thank you very much. Take care. Bye-bye.